All right, so I'm live with 52 Weeks of AWS, continuing the journey to cover the AWS Machine Learning Certification. We're getting close to the end here. I'm going to cover today some additional information, I believe, on computer vision. So let's go ahead and pull that up. I'm going to do that right now. AWS here, I'm going to share my screen. Okay, diving into AWS Bootcamp material here and making things all set up for people that are watching. So either side of the fence will be able to either watch or listen. And I think if I left off before, it was forecasting. So now I'm on introducing computer vision, which is a fun topic. And let's get into it. So in terms of computer vision on AWS, there really is a lot of stuff you can do. I'm going to go ahead and get started here. And to start with, what is it? Why do we care about computer vision? It's a way of extracting information from digital images. And a really good example of this on the AWS platform would be AWS Recognition. They have lots of tools, but that is a great kind of overwhelming way to describe it, is that you're getting information from images programmatically, not just with your eye by visually looking at it. And computer vision can enhance a lot of things that a human can't do. So, you could, for example, extract labels. You can look at the license plate number, right, and get the text directly from something and programmatically put it somewhere. So there's actually things that a human can't do that a machine-based computer vision can do. So what are some of the use cases here? Public safety and home security would be a good example. You could go through and look at certain wanted criminals, right? Like if you were on the FBI's top 10 most wanted list, that would be an easy one, right? You have an automatic alert that shows if those people show up somewhere where they're looking for them. You could also do authentication and enhanced computer interaction. So you're able to maybe help out with some kind of operation that requires the computer to know who you are, personalization, content management analysis. So you can go through here and maybe identify things that you could do to improve content management. Autonomous driving is a very complex and multidisciplinary aspect of computer vision, but there are some components of autonomous driving where computer vision is playing a role. Medical imaging, the classic one would be looking at, for example, the documentation around a X-ray of some kind and try to figure out how to give some kind of medical information. So there's some really big advantages to using this technology in the medical industry. And then manufacturing. So a good one for manufacturing would be looking at the inventory right in a building. If you wanted to go through and make a catalog of all the different products that are in a warehouse and constantly keep track of the inventory without needing to label things, in theory, you could do that with a computer vision system. So what are some of the problems that come up with a computer vision system? Classification, right? So you look at something, you say, what is it? Is it food, breakfast, lunch, dinner? And that's one of the things that you could do when you're training a system, is you may need to train it in a specialized way. And you could potentially train it to do a binary classification as well as a multi-class classification. So you could have it do both. It really is up to the problem you're trying to figure out. In terms of when you're working with objects, one of the things that you will see a lot with computer vision is this boundary box concept, where you are trying to first identify what is a unique object. And then once you've identified that unique object, then you go through and say, what are the coordinates? And then what is the confidence that you can predict each of those particular elements that you've actually discovered? So this would handle both the classification and also the detection. Like, is anything even there for me to do a detection on? And another thing you can do is this concept of object segmentation or semantic segmentation. And this is a problem where you're able to not only just detect that there's an object, but also drag a boundary box around it and get into fine-grained detail. Now, this has a use case in particular with the film industry. This is a classic film problem called compositing, where you would actually take someone and you would composite them, or you would grab them from one still image and put them into another scene. In terms of content recognition with video analysis, one of the things you can do with Amazon Recognition Video is you can capture the position of each player in a video, and you can detect how they move right in real time. A really good example of this is in the sports industry. In fact, I used to work in sports in terms of machine learning, and this is one of the things that we cared about, was this concept of like identifying, who is doing what, and trying to figure out ways that fans could get more interaction with sports. Another one is you can analyze shopper behavior and density in a retail store by following the path that each person goes, and you could even use facial analysis to identify the age range, the gender distribution, the emotions, and you could do this all in a way that, in theory, wouldn't personally identify those people. Another computer vision use case would be with something like Amazon Recognition. You can identify thousands of objects, and some examples could be capturing the batter's accuracy, the pitching style, the type of pitch, slow ball, slider, other inning, batter performance. You could also do initiating things like, based on the speed of the ball leaving the bat, you could calculate an ML model that would do an audio or visual warning about a possible foul ball into the crowd, or maybe a preemptive alarm that has a high probability of being a home run. And so some of these things, like could, again, like a firework. So you could basically start to train models based on the events inside of a sport video image and do various things on top of them. Okay, analyzing images and videos here. Again, Amazon Recognition Service is the main service here for doing this, and it's based on deep learning and enables you to perform different types of analysis, like search images and video libraries, face-based user verification, sentiment analysis, and demographic analysis. So emotions like, happy, sad, surprise. Also, unsafe content as well, text detection. So could you extract, let's say, the bib numbers from people that are running a marathon? All these things are things that can work with recognition. Now, there is something to be aware of in that you would potentially need to identify key issues around the privacy in terms of where you're at. In the European Union, they have much stronger regulation around privacy than the United States, for example. And one of the things you can do with recognition is it's a managed service that lets you do both the image, but also you can do video analysis, and you can actually host models, make an API, scale things out automatically, integrate with S3 for storage. And there's also APIs for all of the common languages: Python, PHP, .NET, Ruby, Java, Go, etc., C++. So this is actually one thing to be aware of, is when you're building something from scratch, versus using a managed service, you can go a lot quicker with a managed service. So here's a good example of a use case: a searchable image library. Maybe people taking things and are uploading the images into a mobile app, which then puts those things into S3. There's a Lambda that does some kind of processing, potentially calls into the recognition API, gets the label, and then once it's got the label that it was able to detect, it would add it to the search engine, and then now the mobile user can actually identify, search through certain features. Image moderation would be another good example. So, a system could check an image that's uploaded, and it could use recognition, and the recognition can actually look for inappropriate content and then basically say whether the content is approved or not approved. So this can be really good in, let's say, an educational-based environment. Another one would be analyzing a video for sentiment analysis. So let's say there's an in-camera camera, and it captures something to a back office, and then the SDK sends the videos to recognition for further analysis, and then the sentiment is extracted, and then the attributes are sent to Kinesis, and then a Lambda function extracts it from the stream, and then the data is written to S3, and periodically that data is loaded into something like Amazon Redshift, which is a data warehouse, and then you could build a report with Amazon QuickSight. So the recognition API is relatively straightforward in that the way it would work is that you would basically give it an object that lives in S3 or upload it as a byte stream of images. And these images could be either JPEG or they could be a PNG format. And when it gives you back the result, it'll give you a JSON that has like a nested structure, like the name is a car, the confidence is 96.94, and the instances, then it shows you the bounding box with the width, the height, the left, the top, and it's got all that basically embedded inside of it. And so it's a nice JSON data structure to build on top of, in that you can actually create a system that utilizes all of the labeling that is happening inside of the recognition API. Also, when Amazon recognition is performing a prediction, it will return back lots of different labels, and each of the labels will have a confidence level associated with it, and that label will basically be something you could use in deciding how you want to write your own system. So this, I think, is a good example of the concept of building on top of another managed service, where you may not want to focus your time on doing something either the same or worse. You could focus your time on potentially building a layer on top of this that said, let's say, a very crude algorithm would be only grab the labels that are 90% or higher, and then you focus on that 90% or higher layer versus focusing on initially creating the layers themselves. And again, one of the really cool things about this is that the bounding boxes will tell you exactly where it's at in your application. Now, for face detection with recognition, a few things to be aware of is that there's this bounding box confidence facial landmarks. So it even will tell you things like the left eye, the right eye, facial attributes, whether there's a beard, glasses, quality, pose, motion. So this is, I think, a really good example of how, if you're just playing around with Kaggle, you're not going to be building something that's this sophisticated. And if you need all of these kinds of attributes, it probably would be best suited for your company to use a high-level managed service. Also, you can compare two images with Amazon to even say, like, are these the same people? Which is actually pretty amazing. Amazon recognition can also search for known faces, and so you could train the model by providing a collection of images to use, and then basically it can go through and say, yeah, I know who this person is, which is kind of a neat customized use case for Amazon recognition, which I could see could be a really strong use case where you could have a relatively high level of privacy, right? Where you could customize something where maybe each user account would have their own collection of faces that were used. That way, people's faces would interact with the systems that are using those. After you've created a collection, you can then do search by face images, and it will return back the image ID of the similar face. So when Amazon recognition does recognize a human face, it captures a bounding box that indicates the place where the face was found in the video. And some of the things to be aware of, though, are that there is actually an emerging form of public safety law enforcement scenarios that I think do need to be taken care of very seriously, especially in the United States, I think, where there is a lot of things happening around user data and user privacy, where people need to be aware of these issues. And this is something that should be carefully thought of. All right, so let's take a look at working with stored videos. This is another really fun thing you can do with Amazon is the start detection, people, faces, labels. One of the things you could do is you could monitor an SQS queue, get detection results, and then do something with them. And so every time recognition maybe publishes completion status, it sends a message, and then SNS can send that to the SQS. And then you could actually keep track of the entire process of processing stored videos. The other thing you can do with recognition is you can recognize faces in a streaming video, which is kind of a neat little feature as well. And so you could actually stream the video to the recognition service and then basically have the face associated with a collection, and then you would get back that result as well. So the use case I could think of for this, for a sports event, is you could have, like, I don't know, the top celebrities of the moment, they change year by year. And then when the camera goes through the crowd, right, it could automatically identify and put in the label for who that person is. So a few things to take away about recognition is that it is a computer vision service that's based on deep learning. You can add images, video analysis. Recognition provides image and video detection of faces, sentiment, text, unsafe content, library search, and it's also integrated deeply into other services. So there's a lot to like about recognition. So the other thing to be aware of is that there are other types of tools. I actually have an AWS Deep Lens device, and you can basically customize training with Deep Lens. One of the problems with a pre-trained model is it'll only find images it was trained to find. And if you give it something new, like in the case of a model that knows how to deal with like common things around the house, and you give it a set of cards, it may go, hey, I don't know what this is, and it'll incorrectly label what that is. And so what you can do with recognition is do this thing called custom labels. And in order to train that, you give you a UI, and you can actually add these additional labels to it, and then use that to potentially customize and augment your training set. So I think this is also a very interesting idea, as well as take a very high quality, deep learning system for computer vision like Amazon Recognition, and then just enhance it by having your company do some kind of labeling process. And here's a good example of a custom labeling process. 1, collect images. 2, create a training set. 3, create a test set. 4, train the model. 5, evaluate. 6, use a model. This is really the process for going through and training a computer vision model, which includes custom labels. So really, step 1, collect images that contain the objects or scenes you want to identify. Step 2, upload and label the images from your computer. So again, you can programmatically do this, or use something like Amazon SageMaker Ground Truth. Create a data set to evaluate the model's performance by selecting an existing data set, or you can even split the training data set for testing. Train the model by using your training data set. The best ML techniques will be automatically selected, and then evaluate the performance on the test data set, and then improve the model by adding images to the training set, and then use your model to identify images with an API operation. So I think this is a very interesting concept that I think many companies should be aware of, is like, should you be doing this, or should you be training computer vision models completely by yourself? And a good example with going through into the details here would be that the process of developing a custom model to analyze images requires time, expertise, and resources, right? And many companies are not going to have those. And so instead, with something like a recognition custom label, you build on top of something else and just tweak it essentially, and enhance what it is that you're building. So one of the things to be aware of about creating a training data set is the data set itself would contain images, labels, and bounding boxes. And you could use those from S3, and you could train the model having at least a couple of labels with at least 10 images per label in order to use that. Now, you could use SageMaker Ground Truth, which is pretty interesting because it can use either people in your company, or you could use Amazon Mechanical Turk. So I've personally used this before. I've trained models using Mechanical Turk way back in the day, and it worked out very well. Or you could use a vendor company to label the images. Now, to train an Amazon Recognition custom label model, your images must be labeled, and the label will indicate an image containing an object, scene, or concept. And you can apply the labels to an image as a whole. And the labels are known as image level labels. So these are useful for identifying the scene or concept you want to, basically detect, like, a beach from Hawaii or something like that. Now, objects with bounding boxes, these are labels that can be applied to an area of an image that contains an object you want to detect. So, for example, if you wanted to detect an Amazon, device of some kind, you could go ahead and create something that would train it on that particular bounding box. So images need labels. So the manifest for an image level label will typically contain the label or class name along with all of the metadata about how it was annotated. Like, for example, and this is really critical, I've had this problem in the real world before, is that did a human create the label or did a machine create the table? I think the label, that's a very important distinction. And also for object detection, the manifest will contain information about each labeled image, and the bounding box will identify when the image object is in the image along with the label the bounding box belongs to. And finally, this is actually one of the more interesting aspects of AWS right now, to be honest, is being able to use a system that can actually label things. This is, it's funny because people talk about all the things that are happening in machine learning, but labeling is one of the more interesting problems that's happening in machine learning. I know Tesla has problems with labeling. They said that when I was there at the last AI day. I've had problems with labeling. Tons of companies have problems with labeling. So can you build a system that can automatically label the data for you, or do you have to have label workers? This is something to be aware of. With Ground Truth, you can enable automated data labeling, and the process is basically like this. So step one, Ground Truth starts an automated data labeling job. It'll create a random sample of objects and sends it to human workers. Step two, when the labeled data is returned, Ground Truth will use the data, the validation data, to validate the models were trained for automatic data labeling. And step three, Ground Truth will run a batch transform job by using the validated models for inference on the validated data. Step four, the automatic labeling component uses quality metrics to create a confidence score, and this is going to support the label quality. Then Ground Truth would run a batch transform job. Step five. Step six would be Ground Truth automates the labeling component, determine the confidence for each object. Step six will produce a data set of unlabeled data with confidence scores, and then Ground Truth will select the data points with low confidence and send them to human workers for additional labeling. And then Ground Truth, with step 8, would use human labeled data and the additional human labeled data to train a new model. The process is completed until the data is fully labeled. So really, this is kind of a combination. It's a nice heuristic that can help you out with your labeling issues. And then, basically the final thing you would do is identify the training and testing set. And once you've got that done, the custom labels can automatically train the model for you. So really, you're building on top of a system, just like you're doing with the rest of AWS. You're using a high-level managed service and building on top of it. And when you're done, then you'd use evaluation metrics. And these are kind of classic things that many people that are already involved in machine learning know about, is the typical classification problem. And this always, the confusion matrix always still confuses me, is that a true positive is a TP, a false positive is FP, a false negative is FN, true negative TN. The place where you see this the most common would be like a COVID-19 test, right? And this is where I think is probably one of the best ways to explain the concept of a classification problem. Confusion matrix is there's 4 different things that can happen, right? True positive, false negative, true negative. In each of those 4 scenarios, some scenarios are way worse than others, right? So if you have someone that's true positive, that's great. You've been able to identify it. If you false positive, maybe that's not that bad in the case of COVID-19. A false negative is very bad with something like a very contagious disease, because you don't want to tell someone that they don't have the contagious disease when they do, and then there's true negative. And so these are ways that people classify things. The other thing to be aware of is that reducing false positives, that would be better precision. And so you can adjust your confidence threshold to improve that precision, and additional classes for labeling for reducing false negatives. So for better recall, you would lower the confidence threshold. You'd use better examples, or you could split your labels into 2 classes that are easier to learn. So that's another thing to think of, is false positives, that's better precision, or reducing false negatives, better recall. And then if you're satisfied with the performance of the model, use the you can do an inference using the CLI or the SDK. That's one of the really cool things about it. Like, just the command line tool interface alone is really an awesome way to interact with AWS. And that's it for today, talking about computer vision on AWS. I think the big takeaway for AWS computer vision is that I think people are too precious about doing all the work themselves, but they're not thinking about things from a business and ROI perspective, especially now that we're going into a recession, or it looks like we're in a recession. I think many companies are going to go, why are we doing things ourselves? Why are we building computer vision models ourselves? Why don't we just build on top of a managed service? And you're still doing, computer vision. You're just using a service that helps you out. Just like if you're deploying something to AWS App Runner, it isn't like you're basically like cheating or something. You're using the service that's the highest level service that supports the problem you have. So I think services like the recognition, ground truth, I think are definitely a very wise choice for many organizations. All right, next week we're going to continue. I think we have a couple more topics to cover before the AWS Machine Learning Certification is ready to be wrapped up, and we move on to something else. All right, see you next week.